Hi, Aya. I just wanted to go over some corrections for you on this assignment. This is assignment 1 from Unit 3, Key Features of Log Functions. For question 1, I've just sketched the graph to the right of your answers. Sorry about that. I'm trying to look at two screens at once here. Okay, so for the domain, for this graph, the domain is all of the x values. And you can see that the graph clearly is kind of stuck at one point, which seems to be around x equals 3. And all the x values seem to be to the right of x equals 3. So for the domain, I want you to write that a round bracket, and I want you to have 3 comma positive infinity, because all the values are greater than 3 for the domain. The range is correct. You can get any value for the range. Your x-intercept is correct, and your y-intercepts, you're right, there are none. When we're writing the intervals where it's increasing or decreasing, this graph is always increasing, and so we show it in interval notation again with negative infinity to infinity like that. The asymptote in this case is a vertical asymptote. That means a straight up and down line. And the equation of your asymptote is x equals 3, not x equals 0, because that's the invisible line that the graph can't cross. It looks almost like somebody's put a fence up along the line x equals 3, and the graph is not allowed to go to the left of that line. For the second function, so the domain is pretty much all of the real numbers for x, but we don't want x equals 0 in this case. And so what you need to do is show a union between two sets for the interval. It's from negative infinity up to 0, union 0 to positive infinity, and that's how you would show that. The range is, right, all positive numbers. There's no x-intercepts. The y-intercept is 0, 1. Good for you. Okay. And so for intervals of decrease, it's decreasing from negative infinity to 0, and then from 0 to positive infinity also. Your asymptote should be a horizontal asymptote at y equals 0. So a horizontal asymptote, it looks like this, and the equation of the lines that are horizontal are y equals, not x equals, and so your asymptote is at y equals 0 there. Okay, looking at question 3, you're right that if we use 1 here, that we're going to get a vertical line at 1, 0, and so that's, yeah, you've got that one right. Going to question B now. With question B, if B is equal to 1, we'll have the vertical line the horizontal line at y equals 1 for the g at x. For the log function can't exist when the base is 1. And so we won't have a point of intersection between those two graphs. Oops. Okay, the graph that you've shown in question 5 will meet the criteria that they've set out. The 0.51 will be on the graph, and you have a x-intercept at the 0.10. And so a possible equation for that would be log base 5 of x. Okay, and also a good job on question 6. This function will definitely give that shape and give you the intercept where they stated. And so that looks really good. So overall, really good assignment. Just pay a little bit more attention to your interval notation and your asymptotes. I think that's one area that you're just not 100% on. But good work, and you're doing very well in the course.